बस थोड़ा पढ़ लेते फिर बाकी निकल जाएगा।
Okay, I think we are live. Yes. So, just a quick recap over here. We are doing the Learn OpenUSD study modules from NVIDIA, and we have completed 6 modules out of the 8 modules provided for the OpenUSD. And we have started the 7th module yesterday, and that is the Developing Data Exchange Pipelines module. And we covered the overview, the setup, and we covered the first submodule, which is data exchange. A quick recap for what is data exchange. Um, so this was basically covering what the implementations for adding OpenUSD support for your data format or application would be. It's basically covering importers, exporters, standalone converters, and file format plugins. Importers and exporters. I don't know, bro. I don't even remember anything from yesterday because what the fuck was. Did we do this actually? Hello.
What?
Did we do this data exchange? We did, right?
No, we were trying to do it, but we did not do it completely, I guess.
We did first part, right?
Oh yeah, we did do the
We did
first
this
part.
for
Yeah, we did do the first part. I think it was data.
uh, data extraction. Yeah, we didn't do data
Oh
extraction.
yeah,
We
we
were
did do
trying to do a data
the
extraction.
hmm
But like when I'm looking at the documentation for what is data exchange, I don't recall reading this. I don't know why.
hmm
Blah blah blah. Yes, we did this. To solve these problems, Pixar built USD with a core set of schemas to effectively describe 3D scenes, including meshes, material lights, cameras, blah blah blah. To get better, OpenUSD it gets better. OpenUSD can also be extended with new schemas to describe the data models for any domain, including physics, robotics, for any domain, including physics, robotics, synthetic data generation, and more. OpenUSD was designed to be able to interchange data between digital content creation software. What do we do with data
Yes, yeah.
exchange?
This is where we at. I think transient data. We were trying to take a look at the transient data part.
I
That.
know, I know. That is in data extraction.
Oh, okay, okay.
I'm just
Doing
taking like a look at
it's fine.
doing like a recap so that we can connect the dots easily.
Mm-hmm.
Okay, so when we talk about OpenUSD exchange, we are asking how do I get data into USD? How do I get my data out of USD? And we may want it out in the same format that it came in. And so we may want it in a different format. For example, we could import an STL asset and export it in GLTF.
Mm-hmm.
So I think yeah, we did look what STL and GLTF were.
Mm-hmm.
Do you remember what they are?
STF and GLT.
STL and GLTF. I know they are file formats, but
Standard. Wait. Standard template library for STL. I don't remember GLTF.
I don't think it's STL is standard template library.
Let's see. Oh, stereolithography. Oh, yes.
Stereolithography and GL transmission format.
Oh,
Maintained by Chronos Group. GLTF is a modern format specially engineered for web, AR, VR, and real time game engines. It's widely considered the JPEG of 3D. Oh, yes, JPEG of 3D, GLTF. It acts like a highly compressed, lightweight delivery package. It stores 3D geometry alongside a complex folder of data that makes the object looks real. Hmm. And then you looked at what nerf was, right?
Yes, nerve. Nerve. No, I know. I do remember nerve completely. Nerve is neural radiance field. In layman terms, it helps you convert 2D objects into 3D objects.
Mm-hmm.
So if you scan a 2D object, it's going to create a 3D mapping of that object. And once we
Mm-hmm.
have that, we can use the polygonal mesh graph to basically annotate points uh, across the grid and do transformations or maybe execute primvars
Mm-hmm.
accordingly. That was the most
Okay.
layman terms as an explanation for that.
Yeah, okay. So is that the best way to encode our nerves? Probably not. We should discuss these issues if and when they arise, and see if we should develop a better way to model our data in USD. So runtime data source, importer, exporter, file data source converter, and file format plugin. So these are the four common implementations for adding OpenUSD support for your data format applications: importer, exporter, standalone converters, and file format plugin. At high level, whether your data is represented as file format or runtime format may dictate some type of implementation, but there are other factors considered as well. Importers and exporters, you may have experienced an importer or exporter in the past. File import, file export menus. And to clarify input and outputs for our purposes, importers translate data from OpenUSD to runtime format of the application. Okay, so this is an importer
Hmm.
which translate data from OpenUSD to the runtime format of the application. So, like basically converting OpenUSD to GLTF or STL over here. Okay, what was stereolithography exactly? Greater than blah, blah. STL is one of the oldest 3D file formats and remain absolute standard for 3D printing. 3D printing?
Yeah,
I thought 3D printing was done by some G programming or something.
that it's an old format, so maybe the new format might be the
Absolute standard for 3D printing, bro.
yeah, one of the oldest. I don't know. Like you can ask a follow up question as well if you want.
It strips away everything except the outer physical shell of an object. It represents the surface using thousands of tiny connected triangles. A mesh. Okay, what it ignores, it literally cannot store colors, textures, lighting, materials, or animation. It only cares about shape. Best used for sending a blueprint to a 3D printer or a CNC machine. The printer only needs to know where the physical edges of the plastic or metal should be, or not what color the object is painted. Hmm. Okay. Got it. These are implemented as part of the digital content creation application for translating to and from applications runtime format. Depending on the application, it might be native feature of the application or implemented as plugin. Plugin might take form of first party or third party development standalone converters. So what does this mean exactly? Depending on the application, it might be a native feature of the application or implemented as a plugin.
So I think we did read like about the plugins and all those things.
Mm-hmm.
So now it's like depends upon what type of application or maybe so, which part we are talking about DCC, right? Depending on it might be feature of it.
Yeah, this part.
But this is DCC, right? Oh, so this is more for conversion of your file that you're trying to bring from different types of format. So maybe some of the formats might be already included in our application, or maybe some of the formats are not included. Then we might have to bring them as a plugin. That's what it
Mm-hmm.
over here. But like we have different types of converters. We have standalone converters. We have import export converters. In this, so import export is basically they are doing one directional conversion, like basically bringing OpenUSD directly into DCC. And now in a scenario where you're not bringing OpenUSD, you're bringing, let's say, STL format or GLTF
Mhm.
format, and that format might not be supported initially in the DCC application, but if
Mhm.
we bring in plugins, then that application will get the support by using those kind of plugin add-ons that will support
Mhm.
third-party formats that were not supported initially. That's
Okay.
what it means over here.
Okay. Standalone converter. The standalone converter is a script executable or microservice dedicated to translating to and from another file format. Okay. Unlike importers and exporters that have clear translation directionality, a converter could be one way or two way. It's important for developers to document what their converter does. File format plugins. A file format plugin are usually a unique feature of OpenUSD. File format plugins. They allow OpenUSD to compose with additional file formats. Oh, and even non-file based sources such as databases and procedurally generated content. What does procedurally generated content mean?
Procedurally generated content. Wait, I think maybe some content that is getting generated continuously from a source, like getting exported, that would be that would mean procedurally generated.
Why do I not remember us doing this, bro,
Oh,
yesterday?
yeah, you were sleepy AF.
Yeah, maybe.
That's fine.
Driven by code, not authors. Here is what procedurally generated content means in this context, broken down into four simple points. Driven by code, procedurally generated content refers to 3D models, environments, or animations that are created on the fly by algorithms, math, and rules rather than being manually sculpted or painted by humans. Okay, so they are generated by algorithm or math.
Hmm.
The instruction manual approach, instead of OpenUSD loading a massive gigabyte size file with static 3D polygons, a custom file format plugin can read a tiny text file containing a few rules. Instead of OpenUSD loading a massive gigabyte sized file filled with 3D polygons, a custom file format plugin can read a tiny text file containing a few rules. Okay. Live generation in memory. The moment OpenUSD asks to look at that file, the plugin executes code to instantly generate actual 3D geometry directly into the computer's RAM. The moment OpenUSD asks to look at that file, okay. A practical example, instead of hand modeling an entire warehouse for a physics simulation, a developer could write a plugin that reads a small script and mathematically generates endless randomized shelving layouts and floor plans the exact moment the scene is opened. Oh, in short, these plugins allow OpenUSD to treat an active piece of software, a generator, exactly as if it were a static file sitting on a hard drive. Oh, I get it. I get it. Here are some key points about the file format plugins. An OpenUSD stage can include a source file format directly as reference, payload, or sublayer. Hmm. An OpenUSD stage can include a source file directly as the source file format is translated on the fly while it is read as a USD document there in USD parlance. The source file format can remain the source of truth. File format plugins can be bidirectional, supporting both reading from and writing to the source file format. They can be used as standalone converters with tools like USD CAT. Okay, this functionality enables various data sources into OpenUSD workflow, allowing for greater flexibility and interoperability in 3D content creation and management. Okay. What do you get from this?
They allow OpenUSD to compose traditional file formats and even non-file such as database. Hmm.
What the hell? OpenUSD's flexibility and modularity make it suitable for a wide range of applications and industries. These features and its universality make the challenges of data exchanges very apparent. Apparent. Come on, bro. What happened? Flexibility and modularity make it suitable for a wide range of applications and industries. These features and universality makes the challenges of data exchange very apparent. Data exchange is typically lossy. Not every data model can be mapped directly. Not every consumer may be interested in all data exported by a digital content creation tool. For example, CAD applications may not need animation data. The content structure exported by DCC tool may not be suitable for every organization and its workflows. Content structure. What the fuck is happening, bro? Why is it not able to do it?
Hmm. I think just
Why?
reload, do a reload, or open a new chat. Maybe I think the context window is overloaded. That might be an issue. Yeah, now try doing it.
So over here, in short, OpenUSD file format plugins acts as instant translators that let you use non-USD files like 3D formats within a 3D within a USD scene like another 3D format. Okay, here's the breakdown on the fly translation. Non-USD files are translated instantly into USD data when you open the scene, so you don't have the manually convert from beforehand. Okay. Keep original intact, two-way editing, and standalone conversation. Keeps the original intact. Because of its instant translation, you can keep your original files as the primary master copy. You cannot only read the original formats but also save changes directly back to them. These plugins can also be used purely as file converters outside of scene. using command line tools, USD cat. Okay. Okay. The content structure exported by DCC tool. Not every client can handle the same content fidelity. Example, high quality fine renderer versus real time 3D app on the phone. Okay, two phase data exchange, transform and extract. So extract and then transform. Okay, two phase data exchange, extract and transform. Ooh. To help with these data exchanges challenges, we propose two phase approach. Okay. So data extraction and data transformation are the answer to these challenges that we are seeing over here.
Mm-hmm.
To help with the blah blah blah, two phase blah blah blah. This loosely inspired by extract transform load used in data analytics and machine learning. So ETL process. But following this two-phase data exchange approach, your implementation will solve many of today's data exchange challenges and help you serve the widest range of customers. Interesting. Okay. Whew. Data exchange to OpenUSD should start with the extract phase. Data exchange to OpenUSD should start with the extract phase. The goal is to translate the data to OpenUSD as directly as possible to maintain fidelity to the source format. Okay, try to map concepts from the source format to concepts in OpenUSD
Mm-hmm.
as much as possible to preserve the integrity and structure of the source data. The transform phase consists of one or more optional steps added to better meet end clients and user needs. This includes applying user export options, making changes to the content structure that deviate from the source format, implementing optimizations for better and end client and workflow performance. OpenUSD Exchange SDK. Okay, OpenUSD Exchange SDK. I think software development kit. Oh, damn. This is a whole new thing as well.
Mhm. Yeah, this is what we are going to use for converting our other format libraries or files into OpenUSD. This is this is going to basically help us create the data pipelines and extraction things like ETLs that will transform everything out.
Hmm. I see. Hmm, hmm, hmm. Helping developers design, build, and test their own USD input output solution, producing consistent, correct USD assets across diverse 3D ecosystems. Uh huh. I see. She says I am the one, but change my mind. Okay. Damn. So USD Exchange SDK helps developers design and develop their own USD input-output solutions that produce consistent and correct USD assets across 3D ecosystems. It provides higher-level convenience functions on top of lower-level USD concepts, so developers can quickly adopt USD best practices when mapping their data, native data, or sources to OpenUSD legible data models. Mhm. Okay, developing data exchange implementation. So I think OpenUSD Exchange SDK is key.
Yes.
All right. Then we did this code, I guess, yesterday,
Uh,
where we implemented a converter,
oh yeah, yeah, we
which
did
is
this. Yeah, we did this.
we
So
converted like an object file to a USD file over
yep,
here.
and there is like the mapping and everything, and how, and we are using the SMPY
Yeah, file library to
yeah.
convert. Uh-huh. Okay, and then in the code, basically, we were doing extraction over here. So for extraction, what we did was input file path, output file path, and then it would give out USD stage at the end. So logger.info executing blah 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 process flag 0 load the object using asm scene equals to asm pi import file string input file and then process flags. So these two are arguments over here inside this function asmpi dot import file, which we have loaded via asmpi, and then define the stage where the output will go. So sd stage usd dot stage equals to usd dot stage dot create new string output file, and yeah, that will get the path from here over here. And what is this str string?
Yeah, string.
Okay. And then for the transformation, to actually implement the transformation, we are passing the USD stage and the arcparse dot namespace argument over here. And then in main, we are passing the arcparse namespace argument again. And then stage is USD dot stage equals to extract from the input and output. Like the extract function is given the argument for input and argument for output, like the paths of the file and the path where the output file is going to be saved. Transform function over here is going to be the place where this transformation gets applied, and they are then gonna save the code. Okay, and then this is the whole logic of data, like a converter.
Mm-hmm.
The rest of it is like boilerplate, I guess. This was the main thing. All right, data extraction. What is data extraction? Benefits of data extraction. Data extraction offers several benefits. Output OpenUSD data looks like it did in the source format, making it easier to understand and debug for developers and end users. This is critical for legibility, one of the core principles of scalable asset structure. Hmm. Pipeline of scalable asset structure in USD. What? Oh my god, bro. Omniverse is so big.
Yeah, bro. Omniverse. It's another universe. That's why it's called Omniverse, I guess.
What the fuck? Bad joke.
What is data exchange?
Yeah, now we come to the transient data again.
Extraction. What is data extraction? Transient data. I think let's give it to Cloud Code, the whole thing. The like that
I
this
did.
you did, and
Yeah, this
explain
is
it to a 10-year-old analogy.
that's what I did. Look at this.
Yeah. Is it processing it? And also tell it,
It's
ask it to visualize it.
done.
It's done. Did you ask it to visualize it as well?
Uh, true. Okay, let's read this first, and then I'll ask it to visualize it.
Hmm.
Imagine your friend gives you a cool recipe, but it's written in another language and on a messy stained card. You want to put it in your family's nice recipe book so everyone can use it. Getting it into the book happens in two steps. Data extraction is the first step, translating the recipe word for word exactly how your friend wrote it before you tidy anything up. The tidying up is the second step, called transformation. Here is why doing that faithful word for word translation first is so helpful. It still looks like the original because you copied it exactly, and you can hold your friend's card next to your translation and check, yep, that says two eggs, that says two eggs. Okay, if something looks wrong, it's super easy to spot on the mistake. Grown up programmers can call this being easy to read and debug. Okay, okay, I read the next part from here.
Hmm.
Read, bro.
Oh, you want me to read? Okay. You can translate it back since you were careful and didn't change anything. You could turn your version back into your friend's language, and it would still match. That's called round tripping. Going there and back without messing it up. It's a clean starting point. Once you have the honest, exact copy, any fancy editing you do later starts from something trustworthy instead of something already scribbled on. The rough
Hmm.
draft part, this is transient data. The first exact translation is kind of like rough draft. A lot of people toss it once they have made the pretty final version, but it's actually nice to keep the rough draft around, because if your sister wants to tidy up the recipe her own way, she can start from honest copy instead of guessing what you change. Sometimes there are also little side notes that don't fit in the recipe book. Like grandma says, don't use a metal bowl. You can always put those in the book. So jot them on a sticky note and keep them nearby in case they are useful later. Matching up the words, this is conceptual data mapping. Before you translate, you make a little chat. This word means the word, and most things have a perfect match, easy. But every now and then, your friend calls. Your friend's language is a word that doesn't exist in yours at all. Yes, that's a tricky spot. Grown up calls it schema gap. When this happens, you can suggest a brand new word for everyone to start using it, and now the whole recipe book gets better for the next person too. So the big idea: first, make an exact honest copy that looks like the original extraction. Keep that rough copy in around in case it's handy, and use a word matching charts to do it, and inventing new words when something doesn't match. Okay. Oh,
Mm-hmm.
oh, okay, okay. Now it makes sense. Okay, I'll
First, make an exact honest copy that looks like the original extraction. Keep that rough copy around in case it's handy. And use word matching chart to do it. Inventing new words when something doesn't match. I see. Hmm. I'll go and wash my face real quick.
okay. You wanna just heat up something?
Hi. I'm Officer Hungover, Fairfax County Police. I can't see with your improperly tinted windows. That's why I was tapping on them. I stopped you for crossing over those solid white lines into that door area. Any reason why you did that? I'm sorry? Well, I appreciate you being honest, but you're not allowed to do that, okay? May I see your license registration? All right, man. Here's your documents back. So I gave you a ticket for the reason why I stopped you, which is crossing into that shoulder bore area. You have to stay in your lane. You can't come into this lane. It's just not safe. I gave you a ticket for the tint because it's like really dark. Should be 50 or 30.
Yeah, bro.
Mm-hmm.
Hey. Okay. I'm not able to understand this fucking part, bro. I'm not able to get over this part. Transient data, what are they trying to actually say?
So do you know what does transient mean?
Like fleeting.
What?
Fleeting. Like leaving.
Yeah.
Transient. Yeah, only for short time.
Right. So that means
Impermanent or staying
it
some.
is it is in the middle of something.
Mm-hmm.
That's how I would infer to.
Yeah. So.
Right. So based on what Lord Code said, right?
Mm-hmm.
So over here, let me read to the transient thing and let's see what it says. So the transient data, the output
Mm-hmm.
you see from data extraction phase is often treated as transient data, right?
Mm-hmm.
So when we have completed our data extraction, now we are in the middle of. We have not transformed it, we have not converted it, we have not mapped it, right?
Mm-hmm.
This is the raw data that is sitting on your
Mm-hmm.
hands, right?
Yeah.
That's what we treat as transient data,
Mm-hmm.
right? Now the author of an exporter will often choose to not write the data extraction output to disk, right?
Mm-hmm.
Since it's transient data and it's not converted into whatever we want, so we are
Mm-hmm.
still keeping it in memory. That's what it is saying over here. And
Mm-hmm.
only the output, the transform data, which is better suited for end users, will be returned to the disk. So that
Mm-hmm.
that
Okay.
what it infers over here is.
But wait, what output USD data from data extraction phase is often treated as transient data. The author of an exporter will often choose not write the data extraction output to disk. Okay, so basically the like the USD, like if there is some external format like let's say STL or GLTF that is put and we have extracted the OpenUSD like conversion from that, the author will not write it to a disk, it will just keep it in memory.
Mhm.
Okay, and
Yeah.
then
So it won't write to the proper end disk where
okay.
the user data will be. So so it might copy it somewhere locally,
Mm-hmm.
right? Like as a backup before transformation, but it won't be
Mm-hmm.
available to the end users.
Mm-hmm.
For example, let's say I'm an OpenUSD developer and you are an OpenUSD developer, and
Mm-hmm.
I was given a task that hey, I need to create a data pipeline that
Mm-hmm.
transforms. Now, I'm in the middle of transformation and getting an
Mm-hmm.
extraction, and I found out that the data that I've extracted is not. I'm not able to map it directly. There might be some issues, right? I
Mm-hmm.
don't want you to read that corrupted file because it's going to break your system at this point when you try to load it in OpenUSD.
Mm-hmm. Because it might not be something that the users might prefer.
Yes, or
Okay.
better suited, not prefer. It is not suited. They can still do, but it will break something.
Okay.
Right now, moving on to the second
But
paragraph.
what will break is not clear right now.
What?
What will break is not clear right now. That's what you're saying.
Yeah, what will break? We don't know. It will. It's an assumption that something might break
Mm-hmm.
since it is raw data that is not completely mapped till now. Now,
Okay.
on the second paragraph, we have author of data exchange implementations should
Mm-hmm.
consider optionally giving access to the in-memory extracted stage or
Mm-hmm.
writing the extracted state to disk as it's valuable for third-party developers that may want to write their own transformation steps.
Mm-hmm.
So now authors are given two options. That is me. I would be given two options: either to write into an in-memory extracted stage
Mm-hmm.
that keeps it local and may create some copy as well, or maybe write the raw data to a disk so that
Mm-hmm.
let's say you are saying that hey, I think I might be able to do the transformation much better.
Mm-hmm.
So can you just
Mm-hmm.
provide me the raw file? And you
Okay.
know that this is a raw file, so it might break. So you might take care of that. If we are
Mm-hmm.
working on a really big, really complex and big database or big OpenUSD architecture, right?
Mm-hmm.
Without it, third-party developers may be left to reverse engineer your transformations. Right?
Mm-hmm.
If you did your transformations, but now the third party developers wants to take a look. How did you do the transformation? What did you use for transformation? How did you map the things out?
Okay. Without it, third party. Yes, I got it.
Or
Examples of transient data from extraction phase that could be useful during the
phase.
transformation phase. Okay. Examples? Why do
Examples
you
like
need
what type
examples?
of transformations we can do? What type of data would a developer or scenarios
Okay.
where a developer face where he would have to be in a phase where there is a transient data,
So
right?
texture and material conversion.
So
When
where you have,
converting between
yeah, go ahead.
formats like FBX and GLTF, materials or textures may need to be converted from one format structure to another. For instance, an FBX material may contain complex shader information not supported by GLTF. So, when converting between formats like FBX and GLTF, materials or textures may need to be converted from one format structure to another. For instance, an FBX material can may contain complex shader information not supported by GLTF. Transient data in such case may take the form of intermediate texture maps, shader definition, or color values that help map FBX materials to GLTF ones. This data may be discarded after conversion or cached in order to be reused for repeated iterations during development. Transient data in such cases may take the form of intermediate texture maps, shader definition, or color values that help FBX materials to get GLTF one. To GL map FBX. Why are we converting FBX to GLTF now? How is it related to USD now?
So GLTF is the standard 3D format, and
I
maybe
know that. I
right
know
now,
that. What is FBX and what is
maybe
GLTF?
so. I'm assuming that we might be converting this because FBX to OpenUSD conversion is really difficult than doing FBX to GLTF and then GLTF to OpenUSD.
What is this motherfucker saying? Imagine your friend gives you a cool recipe, but it's written in another language. Okay, okay, okay. Messy stained card. You want to put it in a family recipe book. Every can use it. Getting into book happens in two steps. Data extraction was translating the recipe word forward exactly as your friend wrote it. Before you tidy anything up, the tidying up is the second step called transformation. Here's why faithful word for translation so it looks like the original because you copied it exactly. You can hold your friend's card next to translation check. Yep. Okay, grown up. Mhm. Since you're careful and didn't change anything, you could turn your version back into your friend's language and it would still match. That's called round tripping. Going there and back without messing it up. It's clean starting point. Once you have a honest exact copy, any fancy editing you do later starts from something trustworthy instead of yeah. Rough draft part. This is transient data. That first exact translation is kind of like rough draft. Lots of people toss it once they have made pretty final version. But it's actually nice to keep the rough draft around because it is if your sister wants to tidy up the recipe her own way. She can start from your honest copy instead of guessing what you changed. Ah, I see. Sometimes there are also little side notes that don't fit in the recipe books, like grandma says don't use a metal bowl. You can't always put those in a book, so you jot them on a sticky note like a separate little file and keep them nearby in case they're useful later. Ah, I see. You can't always put those in the book, so you jot them on a sticky note. Yes, 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 yes. Matching up the words. This is conceptual data mapping. Before you translate, you make a little chart. Conceptual data mapping. This word means that word. Most things have a perfect match, easy, but every now and then your friend's language has words that doesn't exist in your at all. That's tricky spot. Grown-ups call it schema gap. Ah. Oh, I understand this now. Okay. When that happens, you can suggest a brand new word for everyone to start using it. And now the whole recipe book gets better for the next person too. So the big idea, first make an exact honest copy that looks just like the original. That is called extraction. Okay. Keep that rough copy around in case it's handy and use word matching chart to do it and inventing new words when something doesn't match up. Okay. Then you want to see the recipe story. Here it is. The messy card on the left becoming your exact copy on the right with the word matching happening in between. Okay, match the words conceptual data mapping. The source file of the OBJ. The step is extraction. Keep the rough draft. I see plus brand new word. Oh, I get it completely now. Okay. So squiggly blah 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 blah. That's the original 3D file. Green arrow, which you okay. Conversion, three of them, blah blah blah. The fourth has a question mark because your friend's recipe has an ingredient in language that has no order word at all. So you make up a brand new word for it. That's amber row. Okay. Mm-hmm. The neat card on the right is the finished copy. Mm-hmm. It says exactly the same thing as messy one. That's the whole trick of this step. It has to look just like the original, so it's easy to check. And the little yellow stick note says keep the rough draft. Even though this honest copy is just the middle step you might throw away, it's worth holding on to because someone else might want to tidy up the recipe their own way and they'll want to. Okay, okay, okay. Keep the rough draft. I got it completely. Okay. So what are they doing over here? So it's a relatable analogy. Okay, the author is using very common 3D convention conversion problem FBX to GLTF to explain a broader universal concept in data pipelines, transient data, temporary in between data. Mm-hmm. OpenUSD is often the hub in professional data exchange pipelines. OpenUSD use a pipeline that looks like FBX, OpenUSD, and GLTF. The core problem where whether you are converting FBX to GLTF or FBX to OpenUSD, these formats do not structure their materials and shaders the exact same way. An FBX file might have complex shader that OpenUSD or GLTF doesn't natively understand. The transient data solution to bridge that gap, the data extraction tool has to generate temporary intermediate files like baked texture maps or translated color values just to successfully map the original material to the new format. So this is what I think a schema map would be called, I guess.
Mm-hmm.
In short, they aren't abandoning OpenUSD, they are simply using widely understood conversion hurdle illustrated why temporary data needs to be generated and managed when you are extracting data into OpenUSD stage. Mm-hmm. Mm-hmm. Metadata information. Okay, I understood everything. Also, these are just examples now.
Yeah.
So CAD files might contain BIM metadata about material properties, tolerances, or design notes, which may not be relevant for real-time visualization or rendering applications. Okay, transient metadata may take form of filters tagging the information to retain or sidecar files such as JSON, XML, PDF, blah blah blah, containing annotations originally included in the source file. Mm, filters tagging the information to retain or sidecar files such as blah 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 containing the annotations originally included in the source file. LOD conversion. Formats such as FBX or CAD may store multiple levels of detail for a model such as OpenUSD. As OpenUSD or target output formats do not universally offer out of the box support for LODs. A specific geometry LOD must be selected by the transformation process. What does this mean?
As OpenAI target formats do not universally offer out of the box support for. So it means
Yes.
that OpenUSD targets that we are targeting
Mm,
from FBX or CAD, like they have
mhm,
multiple level of detail, but OpenUSD format do not allow those kind of detail out of the box. That means that it's not ready to go. You have to do some fine tuning. It's like you have an open source model, right?
mhm,
And out of the box that model won't work perfectly, but if you fine tune it, it's gonna work. But we can create
mhm,
technology over here with plugins maybe that those formats won't work out of the box with OpenUSD, but with some kind of maybe contextual data mapping or something, they are gonna work.
mhm.
That's what it means over here.
Oh, okay.
Yeah.
In this scenario, intermediate mesh representation or LOD selection metadata may be persisted to disk for use at a later time. These may be carried along the pipelines for downstream use or discarded at the end of the process. Oh, okay. Conceptual data mapping. To achieve a direct and faithful extraction between two data formats, conceptual data mapping is crucial. This process involves analyzing how to map data models from one format to another. You'll find commonalities that make easy for extraction, but you may also find identify description gaps, schema gaps, that is data models from other formats that don't map directly to any concepts in USD. Identifying and proposing new schemas for OpenUSD helps enrich the interchange of our scene description and grow OpenUSD ecosystem. Note: when the source formats have compound of or group data types like structs, records, or group fields, namespace prefixed attributes provide the convention for grouping related properties together in USD. Since USD doesn't have a native struct type, namespace prefix attributes serve as the standard approach for representing the kind of group data. See the custom properties for more on working with namespace attributes. Fuck. Mm. Benefits of conceptual mapping. Producing a conceptual data mapping document as you go through this process can be valuable. It serves as a data specification for extraction, implementation, and okay. Stakeholders can strive to keep the document up to date with changes to source data format, change to OpenUSD, change to an official data mapping implementation. The document enables effective. Oh. The document enables effective discourse when asking for feedback from OpenUSD community or communicating schema gaps. I see. It helps third-party developers understand which features are supported between the two formats and what to expect from the extraction phase, allowing them to develop their own data transformations. Okay, I think I understand data extraction now.
Hmm.
So this was what document, example document overview, this and example, blah, 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 blah. OBJ reference, version reference documents, OpenUSD. So this is the conceptual data mapping over here in
Yes.
this table.
This is how the conceptual data mapping looks like.
Mm-hmm.
Example, but it's not like.
Mm-hmm. The image shows a conceptual data mapping document created for the object to USD converter we are developing in this module. Oh, other examples like USD and Material X concept mapping can be found in the OpenUSD documentation. What is this? Oh, conceptual mapping, data mapping like this.
Yeah.
Oh. You can also check out our additional guidance and template for conceptual data mapping. We hope to see many more conceptual data mapping documents in the future. Okay. Hmm. Okay, I understand this. Here is an example of how data is extracted from OBJ file and mapped to OpenUSD. Let's try this mapping first hand with the next exercise. Exercise, finally. Okay, now that we have a way to parse data in our OBJ file, we can start extracting the information and translating it into OpenUSD. When parsing through each mesh in the scene, we need to make sure the mesh name can be used as an identifier or prim name. Okay. Let's add the tools foundation library to our Pixar imports. Okay. At the top of the file, add tf, the list of the imports from pxr should look like this. Tf usd. Okay. Tool function library. So tf is tool function library.
Yes. Oh, TF is tool function. Okay.
Hmm. This is like the most boring part of OpenUSD for some reason. This is
Yeah, but
like
this
not
is also the
interesting
most
at all.
critical part because now we are trying to bring data from various sources.
Multiple sources. Yeah. Okay. Next, let's add to our extract method right underneath where we define stage and before we call return stage. Uh, we'll add our initial loop to go through all meshes in the scene. In OpenUSD, we need to ensure the mesh identifier is valid before we define it in our stage. Right underneath, we define stage, and before we call return stage, we'll add our initial loop to go through all meshes in the scene in OpenUSD. We need to ensure the mesh identifier is valid before we define it in our stage. We need to enter. So pay attention to your indentations if you're copying and pasting. I think that should be it. And we need to import TF from PXR. Yes. What is this code doing? We are adding a loop to go through all meshes in the scene. Sanitize mesh name equals to tf dot make valid identifier mesh dot name. USD mesh equals to USD geom dot mesh dot define stage f slash. We'll add our initial loop. So we added the loop. Based on the diagram below, we'll extract the first vertex indices of the face and the number of vertices for each face from our object. Okay. Object with faces, vertex points, texture coordinates, primvars st, vertex normal. So this is the conceptual data mapping over here. Bro, what the fuck are you doing?
I'm looking at the object with faces that you showed me right now. I'm looking literally at the screen.
Oh,
Vertex V points, texture coordinates, primware. Like, I'm just following along with you. What can I do at this point?
okay. Oh fuck, bro! I need a massage.
You didn't got your massage from the usual place.
No. Why you? Why you
Why
making it
you what?
sound?
Why
Why are
you?
you making it sound so shady?
I'm not making a sound. Now you have made it sound shady, right? I just said the usual place. Because I don't know the place name. You told me. I think you told me.
It's a sports massage
I
thing, bro.
don't know place name. So that's why I said the usual one.
Why are you putting it like that?
Why you putting like that? Oh, you brother.
Oh, So this is the conceptual data map, and then it is gonna convert vertex into points, texture coordinates in primvars, vertex normal into primvars normals, face into face vertex indices, and face vertex counts still within our loop. Okay, so let's take a look at the loop real quick. How do I close a tab in Ghosty?
Go to the tab that you want to close and do Command W. Not Q. Yeah. Just making sure that you're not doing Q. Q will quit the terminal.
What the fuck? Why is Ghosty so fucking...
Just press enter.
Oh. Alright. Okay, so over here in data exchange. What?
You need to give it sudo. But you cannot do it from over here.
I think I can. No?
What did you do? Like only the shell will be reset to the same file structure. Like you have to do Control C, exit it, and do use cloud code again. Yeah, go back. Yeah, now you can initiate your plot session.
This is fucking ridiculous, man. I hate Miami. I fucking hate Miami, bro.
Bro, what's to hate about Miami, bitch?
But I love 11.
Yeah, bro, 11. Maybe
Those
they
who know.
might sponsor us. I'll be back. Give me a minute while you set it up.
I know you're going to get Swifty in the bathroom. Oh shit. She's Look at this crazy shit, bro.
You got it?
No, I'm just showing it to the people in the chat.
Oh, we have people in the chat.
We had like 3 people watching, so I was just.
Mm-hmm. Cool. Okay. What do we have? Okay, let's try. Oh, dude. I think change the model. Do escape and go. Copy it. Yeah, escape slash model and move it to Sonnet.
So Opus 4.8 was not able to do it.
No, we have an outage. Like usually, Opus 4.0 is overloaded, so it gets an outage sometimes.
Mm. So based on the diagram below, we'll extract the vertex indices of the face and number of vertices for each face from our object. Still within the loop, we'll create another loop to go through each vertex index for each. Bro, why the fuck am I doing all this shit? I don't want to fucking do it one by one. Hmm. So we are creating another loop to go through each vertex indice for the mesh. This allows us to assemble both the face vertex indices and face vertex count arrays from usdgeom.mesh. Add the following code underneath where we define USD mesh. You can use VT APIs here instead of Python lists. So face vertex count indices. So they are initiating to, this is array, right?
Yeah,
Sorry,
it's an array list, whatever you can prefer, like in Python.
list of arrays.
Yeah.
Okay. For indices in mesh.indices, convert the indices to flat list. So face vertex indices dot extend indices, face vertex counts dot append length of indices. Okay. So object is v1, v2, v3, 0, 1, 2, 3 points is 0, 1, 2, 3. Okay, so v1, v2, v3, v4, f2, f1. Face indices of f2 are 0, 2, 3, 0, 2, 3, v and 0, 1, 2. So 0, 1, 2 face of indices f1, f2. So faces vertex indices is 0, 1, 2, 0, 2, 3, 3, comma 3. I don't even know what the fuck does that mean. I mean, I get it what it is doing over here, but I don't know where this came from and why are we converting that? Is
So
that the object?
yes, yes, that's
That's the object we are trying to convert into OpenUSD.
yes. So that is the rendering, but
Mm-hmm.
the file that we are gonna read.
Is rendering that is .obj.
Yeah, so maybe it's an OBJ, but like eventually they're gonna render the same thing. That is the end goal. That what you're trying to render in OBJ
Ah, I
could also
see.
get rendered
I
in
see.
OpenUSD as well.
So both OBJ and OpenUSD store lists of vertices and list of faces that reference their member vertices by index. OBJ keeps one global list of vertices for all objects, whereas OpenUSD tracks vertices on per mesh basis. Fortunately, ASIMP has already taken care of mapping the global vertices of OBJ to per mesh. Another difference to note that the indices from OBJ are grouped on per phase basis, but OpenUSD prefers a flattened list of indices that can be recomposed into phases using what another difference to note that indices from OBJ are grouped to on per phase basis.
Like
Per phase basis.
look
Okay, like F1 and F2.
yeah. So like look at the array. So it's a multi-dimensional nested array, right?
Yeah,
You have a
yeah,
list,
2D.
and then you have two lists inside that. But
Mm-hmm.
how look at how USD maps it out. So
Single.
is it's a flattened, like it's gonna be
Mm-hmm.
0, 1, 2 and 0, 2, 3
Mm-hmm.
in a single array. So that's how that's how OpenUSD takes it, right? And that's how we
Mm-hmm.
will have to map it down. But the other thing that OpenUSD takes is face vertex count, right? How many face vertex we have? That is going to be 3, 3 f1 f2. That is the length of the
Mm-hmm.
array. So
Mm-hmm.
maybe like if we can use length function to define the length of each array in the face indices and just get the face vertex count by using f1 and f2. That's what it is saying over there.
I see. Another difference to note is that oh wait. Another difference to note is that the indices from OBJ are grouped on a per phase basis, but OpenUSD prefers a flattened list of indices that can be recomposed. Hmm. We are not getting as many views as we used to, bro.
Bro, I'm
Let's
telling
go.
you, it's matter of time. Once we are into the magical phase where we just build, then we are gonna
Hmm.
get a lot of views. Like pure building will get us the views.
I see. Hmm. So another difference to note is that the indices from OBJ are grouped on a per face basis, but OpenUSD prefers a flattened list of indices that can be decomposed into faces using an ordered list of face vertex counts. For an example, compare the faces and for faces vertex indices, faces and faces vertex indices. Yeah. So that's what you're saying, right? This is flattened,
Yeah,
like 0 1 2 0 2 3, and this is flattened 0 1 2 0 2 3.
yeah.
And face vertex count is 3 3.
Based on the length of the array of F1 and F2.
So 1 2 3 3 and 1 2 3 3.
Yeah.
F1 and F2. Okay. Okay. The code accomplishes two things. It flattens per face indice into one continuous list. For each face, it counts how many indices it's made up of to populate the list of face vertex counts. Now, with the rest of the information from async, we can create the attributes to define the points, places, and normals of the meshes in OpenUSD. Let's add the following code to create these attributes. Place the code after our last loop, but not inside it. So, what is this code doing?
So it's gonna create point attribute. Oh, it's basically creating, like setting up the USD file that
Mhm,
what are the attributes for our points and the phase vertex count from the information that we got. Like translating, we have basically loaded the data into a raw file, and then once we have that raw file, it could be JSON or something, right?
mhm,
We're gonna load it into the OpenUSD by using our APIs, OpenUSD APIs, such as using create points, face vertex count attributes. That is going to set it, and then again face vertex indices attribute. And then using set getter and setter methods to set them using face accordingly. And once we have that, I think there is something else we are doing. Respect the normal or lack of normal from OBJ. So I don't know what is this USD mesh dot create subdivision schema attribute. This is something like I don't know about. Like line 7, that is what I don't know about. And what is this?
USD geom tokens dot none, bro. This is, I think we have seen this before. Tokens dot
But what
uh,
does create subdivision schema attribute does? I don't know about that. It's fine about token.
subdivision schema attribute means, I think, creating a new schema for thing that was not existing in the USD.
Or respect the normals or lack of normals. Oh, okay, okay,
You
normals. But
see,
what is normal?
for
What is normals?
bro,
You said?
normal is some sort of object entity that does not exist in OpenUSD, for which we need to create a new attribute, I guess. Okay, so let's read over here. Now, with the rest of the information from ASIM, we can create attributes to define the points, faces, and normals of the meshes. Let's add the following code to create these attributes. Place the code after our last loop, but not. Okay, wait. It's worth noting here that we are setting the attribute values in two different default value. Create point attribute face vertex count is set by calling set using USD attribute object returned by create face vertex counts attribute. Okay, create face vertex indices attribute dot set face. Okay, I know what this is doing. Both the ways are available and valid. Calling set opens the opportunity to set time samples if you need to. Also note that we are setting on the subdivision schema. Okay, so they are setting the subdivision scheme to usdgeom.tokens.none so that these meshes are explicitly treated as polygonal meshes, not sub-D meshes, as object doesn't support sub-D meshes. Okay.
Oh, I don't know what are sub D meshes now. Let me look it up.
Okay, so this is the
Subdivision
code.
meshes. Difference between
Oh, we
normal
are done. So
mesh
we just need to run the code now.
and sub.
No, 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 no. No module ASMPy. Do we need to install that?
I think just yeah,
Pip
we need
install.
to install it. Yeah, we need to install it. Pip install running pip install. Yeah, let's copy. That's the module. Let me check. ASM
Yeah, that's the one.
zone. Oh yeah, perfect. That works. A normal mesh is just a polygon geometry you authored and rendered directly, while subdivision mesh uses the coarse mesh as a control gauge and computes a smoother limits. Corrugator mesh is defined by explicit vertices, edge, and faces. A subdivisional surface starts from a coarse polygon. What is coarse? Coarse.
It's still saying the same thing. Why?
Oh, okay, okay. What? Uh, wait. I think there might be. Wait, where did we load it? Let's check. Mm, no, 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 no.
Oh, I think I know what's the
Go
issue.
up. Go up. No, 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 no,
No,
no.
no, no,
Go up.
no, no, wait.
No, because it should install in that environment and it did not install. It did not got installed in that environment. That is the issue.
No, but if I'm doing pip install,
Wait. Do pip three. I think it might be pip three. Wait. Do which pip? Go back. Do which pip? Yeah, there we go. See, this is what. Now do which pip three? Okay, so yeah, we have a problem now. It's not picking up your current location of your environment. That's why it is not able to load it. So I think calling in the big guns.
oh, wait. Hmm. Hmm. Is there a different interpreter?
What happened? So ask him to install it. Ask him to install it in that location. Install it in my Python V and
Okay, so I think what? Oh, it needs arguments. So that is, I think. Bro,
yeah. What happened? Did it work?
Cloud is saying there is a lot of issues with the file that we got.
Is it?
Yeah, in that case, I think we can open issue then.
Wait, let's see, let's see, let's see, let's wait.
Yeah, it ran successfully now. Where did? Okay, shapes.usda. see.
Did it ran?
Damn. Yes.
Okay.
Yes, sir.
So we
Is
want
this
to be
what
have
we
over here.
do?
What did we do? We loaded from an OBJ to
USD.
USD, right?
Yeah. But let's do a diff check for the files. She told me her name was Billie Jean. I got to see. Yeah, bro. The file that they have given does not run.
Oh wait, some what did we change? Import
This
file.
is
Oh,
our file. This is their file.
oh, okay. Time to open an issue, but we are using NumPy.
Yeah, I don't know why.
Why are we using NumPy and why are not they using NumPy? There might be a reason.
I don't know.
Can you
Cloud
ask
code.
Cloud Code that why are we using a num? Because the thing is, it removed np. Wait, did it remove np?
Mm,
Wait, which one was their file and which one is our file?
The right one is theirs.
Okay, okay. They are using NumPy and we are not using NumPy for some reason.
We are using NumPy. They are not using NumPy.
So 13 removals, 14 additions. So wait, left one is ours
Yeah,
and the right one is theirs.
yeah.
Okay.
They don't use NumPy. They are not using
So I
NumPy.
think there might be a reason why they are not using NumPy. Ask Cloud Code why.
No shit, bro.
Okay, yeah, because like I don't want our issue to be like what? Where do you not able to understand? Where are you not able to understand? Maybe it might be a different version that they might be using and asking why are we using NumPy and why is the original file not using NumPy?
She told me her name was Billie Jean. She comes and see. Was not buggy. It was the correct approach for polygon mesh where faces aren't pre-triangulated. The older API handed back structured data. The newer ones What is it saying? The newer ones? Handed back flattened flat buffers and pushes triangulation responsibility to the caller. So the two fixes, snake is rename and triangulation and reshaping, are purely API migration, not logic correction. Uh-huh. Hmm.
So, what did it said?
Why are you not fucking reading on the screen, motherfucker?
Dude, I'm reading it over there, but like I would have to ask in layman terms. What was the issue?
The issue was nothing. It's basically saying it was a versioning issue of some sort. What was that thing? Contribute. She told me her name was Billie Jean and she got the same. But how can we open an issue against this file that does not exist in this repo?
That so wait, just go.
Bro, because
Okay,
because they
okay.
make us download the exercise files,
Yeah,
right?
yeah. Go
That's
go to
it.
Cloud Code. Go to Cloud Code.
Uh-huh.
Ask Cloud Code. Use GH. Yeah, it says go ahead and create the issue in the NVIDIA repo. You know, to just tab it.
Arey, bro.
Tab, I'm gonna tell you, do tab.
But the thing is, this is not a NVIDIA repo. This is not that NVIDIA repo. This is the repo we created on our own.
Which one? The Learn OpenUSD.
No, OpenUSD, and we are in OpenUSD
Wait,
NVIDIA.
wait,
This
wait,
is the known
wait, wait,
OpenUSD
wait,
over
wait. I'm
here.
gonna tell you. I'm gonna tell you. Do that. Just do tab,
Uh,
tab,
okay.
and space. Use GH and
Mm-hmm.
open the issue on the main repo.
Should I give it the link?
Yeah. Learn OpenUSD is the repo.
Oh, somebody has opened that.
And when was it? Oh, on September 3rd. And it's not closed yet. You can close it. You know, you can do a PR. You can do a PR on that. Or maybe somebody might have already created a PR on that.
Yes.
Oh, Matty. Okay, wait.
This is the guy who's
Click on what Matty has said over there.
yeah, this is open only.
Oh. So okay, give
He's
Claude.
saying he's basically saying the data exchange module needs very basic OBJ parsing functionality. Async is a bit overkill, and recent breaking changes in async pi has required us to pin async pi to an older version. My preference is just to write a
Mhm.
simple OBJ parser and include it
This
with
content.
the exercise content for data exchange. Exercise scripts and instructions would need to be updated accordingly. Alternatively, we
Yeah.
can update the scripts or exercises to be able to upgrade to latest SMPI. Tiny object loader seems to be a good replacement. hmm So I think Mojoko USD. Oh, should we give this to Cloud Code and make it
Just ask
right?
Claude. Claude Code can pull the issues. It's not a problem for Claude Code to pull the issues using GH. Just give
Okay.
the repo link, and it's going to pull the issues.
Mm-hmm.
Yeah.
I'm gonna say don't create the issue right now.
Yeah. But make sure to
Well,
ask
the,
ask it to use GH for looking into the issue.
the number 10 issue in using GH, which is related to this thing we are facing. Let's talk about that. She told me her name was Billie Jean and she got the scene. Explore switching to tiny object loader. Wow, Claude knows me, bro.
Yeah, bro, I'm telling you, AI is gonna get a smarter.
Tiny object loader. Oh. He said, I'll be back. One second. 'Cause Jane is the person. Okay. Oh, can we reply to Matty over here?
Yeah, you can.
Preserves the original topology. Vertex indexed one per point. Face varying one per face corner. One more correct for OBJ. Same flat array, same shape needed. She told me Okay, I think I'm gonna add a comment and I'm gonna add a file to Matty's comments over there. So that he knows that we are going through all the OpenUSD notes, you know. Oh my god, bro.
Reload. Oh yes, sir. Ran into this issue while working through data exchange, sharing the finding in its useful current state with latest.
Worth pinning to the RC or waiting on stable release before landing this. Okay, and then tiny object.py. Mm, Let's go. Comment done. It's
On that .py that you have linked. Oh,
gonna just
damn.
download it. Matty. Next stream shout out.
Yes, sir.
Will this be considered as an open source? Oh, by the way,
Yeah.
will this be considered as an open source contribution then?
It could be.
No, right?
But first you have to do a PR and then it should be merged and all those things.
Hmm.
By the way, what?
Yeah, that's what I was asking.
Yeah, it could be. But first you have to create a PR and that PR should be merged and no one should comment on that. What is the part that you're not understand?
Oh, Maddie, Maddie. All right, let's get back to it. So let's understand. Okay, now. modularly. I know that we are converting data from the obj file to openUSD formats to render in the USD view, but let's clarify the major chunks of the functions and their logic. The extract transform, extract transform parts, and what they are doing very simply. Okay, so the classic ETL pipeline over here.
Uh-huh.
Okay, so I understand that in major factories or like companies, we would need to create like ETL pipelines for converting these OBJ files into OpenUSD files as well,
Mm-hmm.
I think.
Yeah, yeah.
Now
Like
I'm
it
getting.
depends. Like if we are getting the data in OBJ files, maybe we can get the data in the other GLTF format or STL format
Yeah,
that
yeah.
we learned about earlier in the documentation. It
Mm-hmm.
could be anything, but OBJ is one of I think profoundly used formats that exists. So we might be using that. So that's why we have that exercise over here,
Mm-hmm.
right?
Let's see what. Mm. Okay. Takes the raw object file and faithfully copies its geometry into USD stage. Reads every mesh in object. Creates a matching USD geom.mesh prim on the stage for each one. Maps the OBJ concepts across V points, face vertex counts, X face vertex indices, V and normal set subdivision scheme, none. So USD treats it as a hard polygonal mesh, not a subdivision surface. The stage is not saved here, it's returned live for the next step. Takes the stage from extract and applies scene level modification, things that aren't about the raw geometry data but about how it should exist in the world. Currently, what the fuck is this, bro? The actual fuck. Okay, got it. Extracting materials. Similar to how we extracted the geometry from our OBJ file, we will now extract the materials. This is the last part of the code that we will be adding to extract. Mm-hmm.
So we will use from Pixar import GF, SDF, SDF. TF was tool function, right? Or
Tool foundation.
tool foundation. Okay, okay. We will sanitize the material, identify that it is dead. And meshes, we use scene dot material, mesh dot
Then
material.
we'll set up the initial shaders. Let's get each material from the mesh. I think, yeah, now I get it why this section is like so least concerning on this. Data exchange is 15%.
It's not the least. Customizing USD is the least.
Where is customizing USD?
Above that.
Oh, yeah.
And then you have visualization at 8%.
Mm,
So pipeline data exchange, these are also critical part of
that
understanding.
is true. Yeah, data exchange and data modeling are actually, yeah, 15, 15, 30, and then plus 23. 53% of the whole exam.
Yeah,
We did content aggregation or we did not, right?
we did it.
We did.
Yeah,
We did it, right? What was in content aggregation exactly?
mm,
Asset structure and all that.
oh, parameterization and payload reference pattern, like working with bigger files, right? Like when you have multiple objects that you're trying to load and offload, then model hierarchy, like it was more advanced and more hands-on experience with how you can load buildings and all those things in a complex scene or scenario, and getting info into like in depth of like using shader API and other shader tools that OpenUSD has. That's what asset parameterization, reference payload pattern, model hierarchy taught us.
Mhm. Content aggregation is 10%. So we did composition 23 plus 10 is 33. And then we did not do data modeling yet, right?
Now, data modeling is the next one. We are doing data exchange right now.
Okay. And we did not do pipeline development as well.
No,
So they fucking put the most of the stuff in the last two modules.
because that's how it's structured. What can we do? Like first, we are trying to understand what is compositions and how do you aggregate content and how do you play with it. And then I think we also learn about customizing USD files as well. So it's all structured.
But where is pipelines? Oh, pipeline. What?
This is pipeline.
Data, data exchange pipelines.
Data
Okay.
exchange, extraction, asset validation. This is the whole pipeline. At first, we learn how we can extract, then we learn about the transient data, and then we learn about how that data can be mapped into OpenUSD once you have extracted it. Now we are trying to work on with extracting the materials from the object file that we have.
Mm-hmm.
Yeah, so we are learning like literally basics of if a raw file is given or if a raw file is
Perform
loaded.
high level perform high level tasks that are important for a well-rounded OpenUSD developer or architect, including designing the pipeline, asset management, versioning, diagramming, documenting UI UX, writing a USD exporter hook to transform data into your pipeline, preferred structure, managing build configurations, and flattening and removing proprietary dependency. But where is pipeline development? This is just data extraction.
So this is everything. Like this is what, like if you summarize everything, that is the whole pipeline that you're trying to build. Like first you try to do the data
But then
extraction.
what is data exchange then? Create a conceptual data map, mapping document custom importers, exporters.
So the importer, exporter, and those were the data exchange part. So we had like multiple types of, like if you go up, yeah, in the second one, below setup, there was a data exchange. You had multiple importer, exporters, then DCC for content aggregation and assigning everything.
Data exchange is this part only, bro. Just this part. And this is
Yeah, so that's what data
15%.
exchange is, like data mapping
Oh,
doc.
that's why we are struggling with this because this is like very critical.
Yeah.
Ah, I see. I see. Hmm. Okay. Anatomy of converter. Pipeline development. I'm still not able to find the pipeline development part. Like,
That's
how are they gonna test this over here?
if you complete everything, like from data extraction to mapping
Uh,
to basically what is
mm,
a pipeline? How would you define a pipeline?
yeah, ETL pipeline. I know
Yeah,
extract,
so
transform, and
like
load,
extraction, transformation, loading, and then mapping,
then visualization.
and then the visualization, like that.
Hmm. But where is the information for that? Like, where is like how are they gonna test us on this? What questions are they gonna ask?
I think that's something that we have to take a look into that.
Into what?
Uh, what was it?
Videos.
Videos, the NVIDIA developer videos.
Customizing OpenUSD for your pipeline.
Yeah.
Pipeline with data modeling. Oh yes, a lot of pipeline questions over here. Oh, I think yes. Hmm. So I think we are done with like 50% of USD right now. We were thinking we had done a lot, but we are still a long way from completing this shit. Mm-hmm. Oh Lord, Lord Claude. All right. Exercise extracting materials similar to how we extracted geometry. We are now going to be extracting materials. This is the last part of our transform. So this is this much only. Okay. Let's do this and then we can do the quiz for today. And
Yeah.
then we should do asset validation and data transformation tomorrow. And yeah, I just wanna fucking increase my time.
Mm-hmm.
Maybe like do 4 hours or something.
Mm.
Because we need to attack this, you know.
Yeah.
Once we are done with the data extraction, we're only gonna be left with one module, I guess.
Mm-hmm.
Oh, sorry, not data extraction, data exchange.
Data exchange.
Like the developing data exchange and pipelines.
Yeah.
Oh, that's why it's called data. Oh, so okay. It's called developing data exchange pipelines. So this contains everything related to pipelines.
Yeah. Like they are showcasing on everything. That's what I've been saying. Like once we have data extraction, then we'll do asset validation. Like those are the steps for your
Hmm.
pipeline. Well, first you do the data exchange, then you do the extraction, then you do the validation of the asset that you created, then you do the transformation. I guess,
Hmm.
and then I think there is asset modularity and all those things.
That is the last
Yeah,
module.
like because then let's say you have a really big, I would assume really big OBJ file, multiple OBJ files. How would you create reference and modularity accordingly?
Hmm. I see. Let's see. Mhm. Bro, it's just Matty who's commenting. Oh, so people are closing stuff.
Yeah. Me. This is me.
Let me see what they did.
What part are you not able to understand? I think I don't know.
Where is the comment?
There was comment. I think it was before. I don't know. The comment was over there. I don't remember it.
So did they dear? I hope you are well, please. Dear, delightful to meet you. Thank you for the support. All the best. What? The f- This is great. I'd love to read the paper. This doesn't seem relevant to this repository.
Yeah, I think the guy was just trying to get the attention of
And look at him.
got it.
Dear. Dear.
Deer. I don't know why people use deer. Like, oh, they have known for a long.
Bro, do you remember that one guy? I think I don't know what his name was, Mohit or something. He wrote "Dear Sir"
Where
and
where?
in FSU, and then the professor was like, "I'm not your dear," and he failed him in the subject.
Oh, is it? I don't know that.
I
Shit.
am not your fucking dear. Dear sir, dear professor. She says I am the one. Okay, let's complete this data extraction. So here we'll sanitize the material identifier as we did in the meshes. Then we'll set up the initial shaders. Let's get each material from the mesh, add the following code. Okay, to get the materials and check if it exists before creating the identifier. This will slot underneath where we define if mesh normal, but not inside the statement. Okay, get She told me her name was Billie Jean as she crossed the sea. Next, we will create the material prim in our stage that has a shader surface for the material graph. Add the following code underneath. Ah, fuck. First, so get the meshes material by index. Scene materials in a dictionary consisting of asym material properties. MTL equals to scene or material. Let me copy this. Last part to the code of extract. But what part am I adding this to? Is it inside the for loop?
The last part of the code that we will be adding to extract to of
Okay.
add the GF.
TF USD. Okay, so we need USD shade as well over here now. If mesh dot normals, but not inside that if statement.
Mhm.
If mesh dot normals, okay. I think like this, probably. Next, we will create the material prim in our stage, and that has a shader surface for the material graph. Add following underneath material path. Where do they want us to add this though? Inside this? Mm-hmm. First, we get the material info from SM using the material index stored in the mesh. You'll notice that we ensure we're using a valid identifier for the material name. Material name, we create a USD shade, not material, USD shade material. No! What? She told me her name was Billie Jean as she crossed the sea. Oh, done. Yes, sir.
Nice.
Come on, come on, come on. Show me. It did nothing. What? It did nothing. Oh. Click on material 001 cube. Yes. And then output surface. Yes. Shader dot output surface. And then metadata is SDF specifier material 001 custom false false, outputs token. Lights. Oh, I see. Look at this.
Ooh, nice. So like the background was loaded through the materials, right?
No, this is default dome light.
Oh.
I don't know why that. Why do they call that default dome light?
Mm.
We have defined the material graph and primary shader for each material, but at this point you shouldn't see visual difference in the viewport. One point of interest in oh is that material names were fixed in this case. TF make valid identifier. Since this OBJ was authored in Blender with material names in format material.001, the invalid character, the period was replaced with an underscore. You can open the OBJ files in VS Code to see the original material names. Okay. Additionally, the expanded output surface property on the material prim shows the connection to the shader prim. Next, let's map the material properties from OBJ to the USD preview surface shader. Copy and paste the code below where we created our shaders. Where did we create our shaders? Where? Oh, get colors. Okay. Mhm, 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 mhm. Bro, if you have like $100 or $50, just put it on Justin Gagey.
All right, brother.
$50, I'm telling you.
I'm gonna put 100 since you said let's do triple
No,
win.
I don't want you to take too much risk.
Okay,
But
where do I go? Where do I go?
Robinhood prediction market,
Wait, prediction mark. What the hell? Sports.
MMA.
MMA.
It's like all the way to the last, I think.
Okay, got it, got it.
And
So
then
Max
Ilya
Hoffman,
Taporia versus
Justin Gaethje.
yeah
All right, so
versus Ilya Taporia.
it's 19 cents and 82 cents for okay Justin Gaethje. And you're
Yeah, put it
saying
on Justin.
Justin, how much?
Put 50, bro. I don't want you to take a
Let's
lot
do
of risk.
275.
Okay.
I will do mid. If I lose, it's the 25 for the rest. Let's see.
Yeah.
Review. I'm gonna win $344 if I win. If
Yeah.
I lose, then 75 is gone. So
Yeah.
no more eating outside. All right, there we go. I'm in.
Yeah. I'm gonna put some more money. I've currently put 100, but I think I'm gonna put more.
Okay, it depends on you. I'm just gonna take bet on you. Let's
I've
see.
put 110 right now.
So, fam, but what is this? Justin Gaethje.
Yeah.
Odds are 20 to 82.
Yeah. 20 to 80. Yeah. Well, like one is to like he's plus 400 like underdog.
Mm.
And also method of victory, I'm gonna go Justin Gagey. I think it's gonna be by points, but
Justin Gaethje. Wait, where? Wait, I did put it now. I'm not able to find it. What the hell?
what? Yeah, it's very bad, bro. Like the fucking
So, wait. I'm in investing. What the hell is this?
prediction markets are very It's down. Like if you scroll down, you need to
Oh,
find the Nifty.
oh, okay, okay, okay,
Yeah,
okay,
they
okay.
need to make like a different tab for prediction markets. I don't know why they have
Oh
put
yeah,
it over there.
yeah, found it. Sports,
Fucking.
then MMA, and then Justin Gagey.
But I'm doing it on like I put the money in on Justin on in prediction market on Robinhood, and then I'm gonna put like parlays on FanDuel. I have this FanDuel.
Oh, nice, nice. Now I'm not gonna
Uh,
go deeper in this than this. That's we have a fight on June 11 as well. Why is Conor McGregor 30?
that's July 11. July
Yeah.
11.
Why
Yeah,
is,
Conor McGregor is making his return. Like I would have gone to this fight if it was not that expensive because that is like a bucket list fight for like every fight fan.
oh, nice.
Conor McGregor, like to watch Conor McGregor fight, it's like
Mhm.
one of those things. Justin Gagey by knockout. If I put 100 on his, that is too risky. If I put Justin Gagey, $100 are winning $450. Should I go deeper in this or not, bro? I'm getting a good feeling. I don't know why.
I don't know. I cannot suggest on these things because I'm not an avid supporter of gambling and doing these kind of things. You bring me markets, I might be able to help.
Wow, wow, that is also gambling, buddy. At some level, that is also
See,
gambling.
that's what I'm saying. For me, this is much more high. Like towards that point, like I will see that I don't have any information on this, and I
Yeah.
don't know who Justin Gagey and whoever the fuck the other guy is. I'm just trusting on you. If I lose, if I lose, that's not this that doesn't matter.
Yeah.
You know, I will ask one of my other friend to do the same. Dude, we wanna make some. That motherfucker is a gambler. Let me text him.
Bro, don't no, bro, don't put
But it's
it.
fine, dude. Here, dude, that is the same guy who made 68.
I'm telling you, bro, this is your risk. I'm telling
Oh yeah,
you.
dude, it's fine. It's fine. No, no, no worries.
I am not promoting anything, I don't wanna. It's just it's one of those times that you get, so cheap,
Yeah,
so good odds.
yeah. I'm gonna
Because
send
most of
a
the
screenshot.
time.
That dude bet on Justin Gagey.
Mhm. Okay, I have added this as well. Now let's map material properties from OBJ to USD preview surface shaders. Copy and paste this code. Now we are created. Here we are setting USD preview surface shader to use specular workflow instead of PBR as it maps most directly to data coming from OBJ. After that we create relevant inputs and set their values from OBJ. This will complete the material definition, but we won't see anything in the viewport until we bind the material to the mesh. Let's bind the material to the mesh. Add the following shader info below. Binding API USD shader binding. Okay.
Look, dude, I can see that a lot of people are betting on Justin Gagey for some reason, based on the analytics like 699,351. That are the amount of people that are betting, and I'm willing to take that.
Yeah, bro, because I think the odds make like those people are degenerate gamblers that you're seeing
Yeah,
because they are looking for a big payout.
yeah.
You'll always find those people, but I am not one of those
Oh my
people.
God.
I am
That's
taking
why
a
you are
calculated risk.
betting on right? Not betting on Ilya Topuria.
Bro, Ilya Topuria is my favorite fighter. I'm telling you.
Oh, oh
But
yeah,
it's
pilot.
what?
Oh, I was taking a look at the compilation.
Yeah. Okay, so now we have colors as well. And lights, enable default lights. Oh, look at this, bro. It's doing all the reflection shit and everything. Nice.
I'm gonna tell another gambler that I have that loves to gamble. Right, I'm gonna let everyone know. If I lose, every other motherfucker is gonna lose with me.
I'm telling you, bro, you're gonna lose some relations.
Never mind, bro. I have made them money as well. I would definitely say, be on a fucking gamble.
Mhm. Okay, look at this, bro. This is the dome light. And then if we turn the lights off, oh, it's still gonna look at that. Oh. Oh. Okay. Bro, do it after the stream, bro.
Never mind. The messages are away.
Root.
If I win, those motherfuckers also make money.
Yeah.
All right.
Notice the
What
diffuse
happened?
and
Material properties. Okay. How
spectral
mapping
material.
material. Blah blah blah. Okay. So we first load them into a variable and then use shader.create input, that library, to map those. And then we use binding material to add the following. Okay, okay. I see. Have we completed the mapping?
Yeah,
Nice.
it's complete. But I think we should take a look at the full complete file
Yeah,
in
I was
Cloud or
going through the
something.
file only that we have.
So we have done the extraction, right? In this complete data extraction. Extraction of data and conversion into USDA, specifically the extract function line by line, very simply by understanding the goal of each line there and surgically understanding what is going on. Convert this data. You said there was an outage in Opus 4.8?
Sometimes there's an outage. Like you can check it on status.cloud.com and let me check. Cloud code operational 3 June, no downtime recorded. Yeah, I think as of now there is no downtime.
Mm-hmm.
Oh yeah, Cloud Code has an outage, partial outage, 16 minutes ago.
Cloud code. This is Cloud.
Cloud Console, no, Cloud
But
Console.
it is working, so I think.
Yeah, Cloud Code does have a outage for since 16 minutes, 3rd of June. And on 2nd June, the outage was still going, so it was so like the outage was on multiple models, so that's why we were not able to run it properly. Like the outage lasted for 4 hours, and then I think the outage is continuing into the next day.
Mm-hmm. Yeah, I think this is fucked for some reason.
Yeah,
Time to go back to the OG where it all started. Literally, bro.
the ending is the beginning.
Dark. Sam Altman be like, huh, bhai, where did your failures lead you? Back to me.
Arey Baba. Wait, I have a specific meme.
Oh, never mind, it worked. But let's compare the outputs. This is the exact code behind object to USD mapping diagram. Now you get to see each arrow of a line of Python before walkthrough. The shape of the whole file. Extract is the faithful translation. Your exact copy. Transform is the empty tidy up. Stub you would fill later, and main runs extract transform. Save the stage extract. Hands back is the transient extracted. What the fuck? Before the walkthrough, the shape of the whole file. Extract is the faithful translation, your exact copy. Transform is the empty tidy up stub you would fill later, and main runs extract, transform, and save. Extract is the faithful translation of your exact copy. Extract and hands back is the transient extracted state. Saved inside extract, going through extract and order, set up 3 lines, process flags. Yeah, everybody wanted to triangle as it loads. This one choice is the reason every face is size 3 later. So deliberate mapping decision, not an accident. Async reads the OBJ and hand back on
Like a brand new USD Prim must be legal object geometry Ravi split into meshes.
you. See what this motherfucker is saying. The central idea is OBJ file passed by async, async scene object in Python memory translated by extract. Okay, USD stage containing mesh plus material plus shader prim stage.save USD a text file on disk. Yes, we know this. NVIDIA's exercise describes extract as the phase that maps the source OBJ into OpenUSD. OpenUSD as directly as possible. Optional structural or import export changes belong in transform. The most important mental model. An OBJ file may contain data like. Yes, conceptually async reads this and gives Python something like mesh.name triangle. How did this know that this is triangle? Oh, triangle 0, 0, 0, 1, 0, 0, 0, 1, 0. And then 0, 1, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 1. So, mesh name is triangle, mesh vertices. Or 0, 0, okay. Mesh indices 0, 1, 2, 3. So, mesh normal. Oh, if you run this and gives Python something like this, the extract converts that into USD mesh prim. So def mesh triangle 0.3f. Oh, so this is how the conversion is happening.
Mm.
Int face vertex count, int face vertex indices. Normal 3F, normals. Mm, okay. The complete role of extract in USD point stores positions while face vertex indices and face vertex counts describe how those positions are assembled into faces. Face vertex indices is one flat array, and face vertex count is how many consecutive indices belong to each face. The complete role of extract, your function is def extract input file path, output file path, USD node stage. Take one OBJ file path, read its geometry and material information, create new USD stage, author equivalent USD meshes and materials into that stage, return that stage to be later saved. Yes, okay. So, okay. Beginning of the extract, load source and create destination, goal, input file, output file, USD stage. Yes, USD stage and the return. Is the USD scene graph being constructed? Yes. Logger in for executing extraction? Yes. Process flags? Yes. An OBJ object face can originally be F1234012023 where triangulation asymptotes into triangles conceptually. Post-processing step splits imported face containing more than three indices into triangle faces. Every face has exactly three vertices. Mm-hmm, 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 mm-hmm. Are you watching this or what are you doing?
I'm watching it. Scene dot meshes, scene dot material. I'm looking over there. What are you trying to read?
Okay, the SIM binding exposes mesh data such as vertices, normals, material indices, textures, coordinates, and material through the imported scene. Share object
One thing is
text.
SM parser. That is basically parsing everything based on the understanding I have till now. And once the SM parser parses everything, we can load it using Python directly and then use the OpenUSD development toolkit to
Mm-hmm.
map out into OpenUSD. That is the most important thing. So I think that is where whatever we have learned till now, like
Mm-hmm.
basically we are doing a hands-on over here that data extraction,
I think let's read this code and then whatever we don't understand, we can look it into
yeah,
that. So here's the extraction logger, process flag, scene, stage. I think this is creating the new output file
output
stage.
we want eventually in the pipeline. This is a pipeline completely, kind of a way,
Yeah.
maybe not complete but partial pipeline. Then once
Mm-hmm.
we have that, we are going to use scene dot meshes. Now the scene
Mm-hmm.
dot meshes comes from the isimpy dot import file thing that
So
are loading.
sanitized mesh name equals to tf dot make valid identifier and mesh dot name. So whatever meshes are present in scene dot meshes.
Mm-hmm.
And what is scene dot meshes exactly over here? Did we define it?
Yeah, we
No.
defined it on line 28.
That is scene. That is not scene. Oh, scene. Yeah. Okay.
Scene dot meshes. So scene is that's an object. So when you
Mm-hmm.
load it in the scene, there is an object. You see class string object. There is
Yeah.
kind of object that we're trying to load, and then the import file like sm dot underscore py takes care of that. That is the best part. That
Mm-hmm.
because it's a parser, so it parses into an object. I'm assuming, and once
Mm-hmm.
we load that object into a scene, then we can use scene dot meshes that might have like other objects, like one of the object would be scene. We can print scene as well to look at what objects it has,
Mm-hmm.
right? Or maybe look at the sim.py import file thing. Let me see.
Mm-hmm.
Uh, sim underscore py dot
Oh, cube. Okay.
import output.
Mm. Yeah, I think let's look at this tomorrow now,
Yeah.
and we can do the quiz now.
Okay.
I need to sleep. I
Yeah.
need to go to the office tomorrow.
Yeah. But I also have to go to the office tomorrow.
Where's the fucking quiz? What? Yeah. All right. How many questions do you want to do?
So there's the 20.
Okay. What is the difference between
Well, and
instanceable and prototype? In the context of USD instancing, instanceable prims are rendered as bounding boxes while prototypes are fully rendered in full detail. Now, that is not true. Instanceable prims are simple copies while prototypes allow for overriding properties on each instance. Instanceable prims are defined within the same USD file. While no, so this is not true. Instanceable prims are read only while prototypes are editable. That is not true. So I think B.
I would go with D. They are not, first of all, simple copies, instanceable.
Read only while prototypes are editable. I don't even know what prototypes are. We have you used them?
I think I did saw a similar kind of question earlier in this quiz, so that's why that is my best guess. And C, I'm not going with C because like prims, instanceable prims are defined within the same USD file. That is not the case. It can be defined in other files as well. So that's why I'm gonna go with D. And A doesn't make sense. B is incorrect technically because they are not simple copies while prototype allows for overriding. Like the first part is incorrect. I don't know about the second part, right? That's why I will just go with D.
Hmm. Wait, let me ask over here.
Yeah, but can you like do check and answer, then we can verify it later. No. Okay, let's ask over there.
I was right.
Simple copies while prototypes allows. Okay, let's ask now.
What exactly is instancing in OpenUSD? I know it's instancing means referencing and everything.
Yeah.
What the hell,
Maybe your
bro?
context window is overloaded. That's why it won't work. Uh, now
I can't read this
I
anymore.
think this question is wrong. Maybe I just ask the question.
Hey, bro, wait.
Uh, Dude, this is how many times am I gonna learn about instancing? It's gonna be the
Well,
same.
okay, wait. Tell me. Tell me, okay? Don't read that.
Yeah, I
Tell me.
know. So instancing, you remember if you reference a file, if you and put
I
instance,
know that. I know that.
then what do you want to
And
know
other than that, what is instancing?
other than that? That is what you do when you make it true. Then you can create multiple copies, not multiple copies, create a reference copy in your memory buffer, right? And then you can refer that memory buffer n number of times.
That is just referencing. That is not exactly instancing. You're just referencing.
No, but you have to, when you do instanceable true, then only it will become an instanceable prim. That's what I'm saying.
Instancing computes a repeating 3D asset just once
What
to
did I say right now? What did I said right now? That was the same thing that I
repeating.
told you.
You said, I know, bro, it's referencing. I know
But that
that
is
we
so
make the
instanceable is
instanceable equal to.
not a
Wait,
not a single concept.
wait.
It is always, it will always be with referencing. You cannot do like, you cannot go and basically
It is
assign.
not saying referencing over here, by the way.
Yeah, because
Compute a
you just
repeating
asked for
3D
instancing.
asset.
What is instancing, right? So, but the way you use instancing is
Okay, wait.
with only referencing.
Declarative deduplication of repeating elements to create highly efficient scalable 3D scenes instead of evaluating and storing blah 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 blah. The result.
What that is referenced by all copies, drastically reducing the memory footprint.
Okay, wait. The result is a shared prototype that is referenced by all copies, drastically reducing the memory footprint and accelerating scene composition time.
It's gonna share the same memory buffer.
So instanceable prims are simple copies of overriding properties on each instance.
That's why
I
that
think this is right.
the simple copies. Why we are not creating any copies? I would guess it's gonna get
Bro,
referenced by all.
insensible prints were copies. Bro, you remember what they did?
Result is then
What?
referenced by all copies.
What?
The result
Instead of
is
the
just
result is
just copy
shared
the quiz.
prototype.
Copy the
The
quiz.
result is shared prototype.
Just copy the
That
quiz.
is referenced by all copies. This copies is instances.
Just copy the
Bro,
report.
look at it. Instancing is declarative
Just copy
deduplication of
the quiz.
repeating.
Just copy the quiz. And
Bro, you
I just want to
fucking.
verify that. If that answer is correct, and then we will take a look into that. First, I want to verify if I don't want to waste time on that.
I want to read this. Insensible prims are simple copies of the source prim. Fuck you. Fuck
This
you.
is what I want to learn. You're making me read the whole fucking thing. This is what I want to know.
That's what I was saying to you over
But
here
why
as
do you
well,
want to read the
buddy.
whole thing? That's what I was trying to say you. That just copy that
Bro,
shit.
I wanted to fucking.
Go,
Bro,
go
now
to
another
learn
question will come
OpenUSD. Go
about.
to learn
No, wait,
OpenUSD,
wait,
Ali.
wait, wait. No, 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 wait. Another question will come about scene graph instancing. And then we are
Yeah, I
gonna
know.
search about this again.
So,
Instead of searching it
instead
again,
of
we're
that,
gonna
we can
answer it over
directly
there
refer to learn
and then go
OpenUSD
to the next
documentation and
question.
go take a look over there. That's what I would do.
Here is the difference, okay? So you're happy now?
Yeah, so
Insensible
this is
prims
what I
are
want to
simple
know basically,
copies of
that
source
are
prim.
simple copies of.
Prototypes allow overriding properties for on exactly the answer that I was trying to
Okay.
select. While insensible prims are highly efficient for creating straightforward duplicates, prototypes are offer the flexibility needed for more complex setups. By using prototypes, you can define specific property overrides on a per instance basis, allowing for individualized variations among your instance objects. Okay. Scene graph instancing, native instancing best for complex assemblies with deep hierarchies, such as vehicles, fully rigged characters, or intricate architectural modules. When bringing a blah 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 like reference or payload, you tag the root prim with a metadata instanceable equal to true. Okay. Point instancing best for massive quantities of simple items where overhead maintaining. So next questions are going to be about scene graph instancing and point instancing. I think
Okay,
I'm gonna see
let's see.
what you're gonna do.
You need to create a USD scene that can be easily translated into different coordinate system. What you should consider.
Coordinate system using relative coordinates and root transform.
A
Embedding the coordinate system information using custom shader to
prim vars.
using relative what?
Prim vars we used.
Wait. You need to create a USD scene that can easily translate it into different coordinate system. You should what should you consider using a custom shader to transform coordinates?
Yeah, I think I might be wrong, but I would go with this. Using relative coordinates and a route to transform.
Mm, yeah, using relative coordinates and root transform. Using relative coordinates and root transform allows you to easily translate entire scene by modifying the root system.
Oh,
Root trans.
okay.
Let me see
Yeah,
if this
let's
is
go
correct.
deeper in this.
These questions are good, bro. The like this new quiz is better.
Let's see.
Using relative coordinate and root transform. Yeah, exactly what the option is.
Mm-hmm. Okay. Efficiency and flexibility by defining everything relative to a single transform. You can easily translate, rotate, or scale. Oh, okay, okay. Oh, I think avoiding complexity. Other methods such as using custom shader to transform. Wait, B was also say. Look at the second option. Second thing.
Other methods such as using custom shader to transform coordinate. Right.
I think you did copy the same one, right?
I know, but I removed the test, so I am trying to see if it gives the complete information. Oh, bro, I think it's hallucinating.
Dude, I think for some reason Gemini sucks. That's why I use Perplexity all the time.
Oh my god, bro.
What the fuck? Wait, let me use Perplexity. Zoom out. Zoom out. I'm gonna just give the whole thing. Remove the Gemini thing. Remove the Gemini thing. Piece of shit. Yeah. Where is Comet?
Oh, okay.
Oh, I do remember. Other thing was you can also change your screenshot by default to .jpeg in your Mac OS setting, so that you
Ah,
yeah, so that you don't have it. That's what I did for my settings as well. I think I did ask Perplexity the same question when I made.
HEIC from HEIC to
Yeah, so
JPEG.
it allows you to select which format you want.
Mm. Oh shit.
Okay, okay, okay. So it says that the correct answer is definitely using relative coordinates and a root transform. In OpenUSD, X form prims apply transform hierarchically to their children. So a parent or a root transform can move the whole scene without rewriting every child object's position. Why it's correct? Authoring objects in local or relative space under a top level root XFORM makes the scene easier to translate into different coordinate system because you can adjust the root transform instead of modifying each frame individually. And why the other choice is wrong? Because using a custom shader to transform coordinates is the wrong level of abstraction for this problem because shaders handle rendering behavior rather than scene graph, scene organization, and a spatial hierarchy. Oh, okay. So shaders are mostly used for rendering behavior rather than the scene hierarchy over here. And it was this question was based for scene hierarchy.
Mm-hmm.
So I think we were not also able to understand the question completely. What did the what did the question mean? Well, let's see what did the question meant. How should you structure the scene so it can be moved or remapped into another coordinate frame easily? So in USD terms, the question was really testing whether you understand the transforms and should you usually be handled through scene hierarchy using local transform and a parent slash root transform. Oh, okay. So that question is testing our knowledge on the transform part and how we can remap one coordinate into another. No,
Mm-hmm.
that's why. All right, let's move on to the next one.
Mm-hmm. Let me understand this first, though. Okay, we move to the next one. What is the primary purpose of USD scene description language?
Mm,
To define 3D assets and the relationship. Right.
question 4.
What is the purpose of USD shader? Material properties. You want to answer this or should I check?
What is the purpose of USD shader to define all or to manage lighting to define?
Oh, wait, compute the surface appearance.
I was gonna go with that D.
Surface appearance
Of
of an object.
shader, that's like they have diffuse color and other things, right? So that's how.
Yes,
Uh,
yes. A developer is tasked with creating a custom USD viewer that supports different rendering engines. They want to ensure the viewer can easily switch between renderers without modifying the core code. What is the best approach? Implement a custom rendering pipeline for each engine. What? Use a third-party rendering library, write separate viewer replication. Hydra rendering framework. I think fourth one.
A developer tasked with USD viewer that supports different rendering engines. They want to ensure the viewer can easily switch between renderers without modifying the core code. Mm. Yeah,
Yeah, I think
yeah,
it's
yeah, I think yeah, that is the most appropriate one.
yes. What is the best approach for creating complex rig for animation in USD? Define rig.
As approach for creating a complex rig of animation, define the rig within. I think skeleton would be.
This one.
Yeah, I think there is some kind of USD skeleton that we read earlier.
USD scale,
Yeah,
not skeleton.
but that's the skeleton thing related to. But let me USD skill if there exists something like that. Yes, there is a skeleton schema API.
Oh yeah, it's right.
Yeah.
skeleton skinning and animation.
Yeah.
What the skeleton skinning?
I think it might be wrong. Let me just verify over here. Yes, skinned mesh. Yeah, yeah, scanning. That is correct. Correct. Skinned meshes and joint animation between DCC tools in a graphic pipeline.
I don't think we're gonna get questions like this.
But like this is basically testing our knowledge, right? I know we are not gonna get questions like this. We are gonna get more
Oh,
related.
Matty specifically said in that video that you're not gonna be tested on like
No,
okay, we
I
are
know, but
doing
this is
this
for our own internal testing, right? So like,
internal, yeah,
how to
yeah,
use this? What is the
soul
solution?
healing, yeah, yeah, yeah. When composing multiple USD layers, what determines the final value of an attribute if the layer contain conflicting opinions, layers with highest edit target priority, layer with
Yeah,
earliest
okay,
creation date, layer with most of
priority target.
the layer listed last in the composition arc.
No,
Last? Last means like the highest?
no, low. Last means yeah. This is something. Wait, let's do option elimination. The layer with the highest.
The highest edit target. No, but
What
when
is highest
composing
and what
multiple.
is
Oh,
low?
wait. When composing multiple USD layers,
It's layer. So it's gonna be the first one.
what is the final value of the attribute if the layers contain conflicting opinions?
So always the first layer would be given. So last won't be given any priority. Always the first layer will be.
Layer with the highest edit target priority, layer with the earliest creation date. Most author attributes is not gonna be the one. Highest edit target, I think it's gonna be B.
B.
Because yeah,
What do
this
you mean
doesn't
by
make
earliest
sense,
creation
yeah.
date? Why do you think it would be B? What do you mean by earliest creation date?
Because earliest creation date would mean that it is like the root layer.
Uh,
I
but we
think
are talking about sublayers, right? Over there, multiple USD layers. Okay, no, we are not talking about sublayers. Earliest creation layer, or why not A?
highest edit target priority.
Yeah.
Oh wait, what is highest edit target priority exactly?
I'm just assuming that the layer that is on the top.
Wait. What is edit target priority in OpenUSD? Quick, bro. Quick. What the fuck, bro? Okay. Instead, edit target and opinion priority are two interacting concepts. Edit target. The stage is the final flattened image you see. Think of USD stage as a composite image made of any transparent Photoshop layers. Edit target is specific layer you currently have selected to draw on.
Highest. What does highest mean?
If you set your edit target to sublayer B, the author radius 5, sublayer 5 already has radius 10, your it will be successfully returned to sublayer B, but stage will output layer 10.
Highest. What does highest? No, you have not mentioned the highest one over there.
What the fuck is the time, bro? It's 1:10.
Yeah.
We're gonna do 10 questions, bro.
Okay.
I need to sleep. Yeah, bro, it's gonna be A. I
Yeah.
think it's gonna be A. Look at this. In OpenUSD, having the highest edit target priority means you're writing to your data into the layer that sits at the absolute top of the composition hierarchy.
Yep.
Because of how USD resolves data, blah blah blah. I think it should. What? This is wrong. This is definitely wrong. The layer listed last in composition arc typically overrides a what?
Give him
So
all the options as well.
who's back? Let's see the next question. What is the difference between uniform and varying attributes? Uniform attributes have the same value for all points on the primitive, while varying attributes can have different. Layer listed first in the composition arm?
What is saying? Let me ask Perplexity if it is giving up something else.
But it is not first in composition arc, it is last.
Yeah, I know. Fuck, it's gonna rain. But when,
Oh, what, bro?
dude, if it rains, it gets more humid. The temperature rises. That is a dude. You know how much was the temperature today? 105.
What the fuck?
105, dude. 105. I went to Sam's and on my car, I was taking a reading and it was like 105 Fahrenheit. I'm like, fuck me. Fuck me. My car's AC was on blast. Still nothing.
I'm so glad I moved to New York, bro. I don't feel hot at all.
Yeah, because you feel cold AF.
Yeah, but summers are really good. Like it's
Yeah,
15,
I know,
16
I know,
degrees.
I know, I know that there's a reason for that because there's no
Yeah.
Himalayan ranges unlike India. India is also like churning 105 Fahrenheit.
You know how much it's gonna be tomorrow? The average is gonna
Delhi's
be
Delhi
63.
is 94. Fuck.
Sheesh.
It's like you can boil fucking water. If you put eggs
Yeah, I
on your
know.
bonnet, they're gonna get cooked.
All right, next question. Uniform and varying.
Hey,
Same value for all points and different values. Yes.
yeah, I can
What
see
does,
that 63. Fuck you guys. Fuck you. New York is at 63.
yeah. What does the term opinions refer to in context of OpenUSD layering and composition? The artistic preference applied to a scene, data values defined in specific layer, comments added to USD file,
Read the settings for
rendering.
a specific shot. What
I
does
think it's both B and C, but we need to choose B. It's also the metadata and oh, not the comments. Sorry, not the comments. So it's gonna be
Yeah, I think it's gonna be data values. Yep.
yeah.
The
And
last
it's
one.
also it's not just opinions are not just data values. They're also metadata and relationships. They are
Yes.
also called opinions.
Yes. That's also true. When should
When
you
should
use
you
insensible prims? We strike
create multiple copies of an asset?
A.
Let's do no, yeah. Let's let it be. I need to go.
All right. Perfect.
Ooh, let me end the stream. Adios, amigos.
Adios. Peace out. And just in
Nobody
case,
watching.
when's the fight tomorrow, right?